In Lesson 3-1, we will be discussing exponential functions. In Video 3.1.5, the learning target will be to solve problems involving exponential growth and decay. In Example 5, we will be asked to use the continuous compound interest formula. In the last video, we learned about compound interest, and if it is compounded continually, or not continually, quarterly, monthly, yearly, daily, etc. But now we are looking at a separate formula where the interest is compounded continuously. If a principal P is invested at an annual interest rate R, again in decimal form, is compounded continuously, then the balance A in the account after T years is given by the formula A equals P times E to the RT. Now, this is going to be similar to the compound interest formula where the interest is compounded monthly, quarterly, yearly, daily, etc. P is going to be our principal or the original amount invested. E is not a variable but rather a irrational number, which is approximately to 2.71. You can find all the digits of E under, if you press second and then ln on your calculator, you'll get a little e to the x power. That will give you the base E that you're looking for, rather than rounding E to 2.714 and approximating it. R is the interest rate, and it has to be in decimal form. So if we had a 10% interest rate, our decimal would be 0.10. If we had a 3% interest rate, we would have 0.03 as our value of R. And T is equal to time in years. And we're going to use this formula, again, only when it's told to us that the interest is being compounded continuously. In Example 5, Part A, we are going to look at using the continuously compounded interest formula. And we have the same person, Mrs. Solisman, investing her $2,000 at a rate of 5%. We want to know what her account balance would be after 18 years if her interest is compounded continuously. So again, A is the amount after T years. That's what it's in the account after T years. Her initial investment, P, is $2,000. We multiply that by E, which is the irrational number, approximately 2.71. And we're going to raise that to the interest rate, 5%, times the amount of time, which is 18 years. So I'm going to type this into my calculator just the way I have it written, 2,000. To get this E, to get all the decimal places, I press second ln, which is on the very far left side of your calculator, maybe 2 buttons above the on button. And I'm going to raise that to the 0.05 times 18. Okay, so on my calculator it looks like this. I'm going to do 0.05 times 18 inside the parentheses. And I get a value of $4,919. And if I round to the nearest cent, 21 cents. That will be the amount in the account after 18 years if the interest is compounded continuously and the $2,000 is in there without any additional withdrawals or deposits. In the Example 5 guided practice, we are looking at a situation involving online banking. This time, if $1,500 is invested in an online savings account earning 4% per year, compounded continuously, how much will be in the account at the end of 8 years if there are no other deposits or withdrawals? There are 4 possibilities here. A, B, C, and D. I would like you to work out this problem and then submit your choice for the response or answer.